Algebra I, 12.2a, Recognizing Functions. A function can be written several different ways. It can be written as an equation, so we might see y equals x plus 4. We might even see an equation like the function of x equals x squared plus 2. It could be written as a set of ordered pairs. We could have x and y values of 2 and 3 and 7 and 8. And we can graph those ordered pairs, and that would be a function. If you look, this is x is 2, y is 3, and this one is x is 7, and y is 8, and this graphed line is a function. It can also be arrows. We could have ordered pairs that when we graph them, they end up making two arrows like this if we graph the points, see? So there's several different ways that a function can be written. An equation, ordered pairs, a graph. We could do it with arrows, see? Here we have one line, here we have two arrows, see that? So the domain is the input, it's the x-coordinate. The range is the output, the function of x, or the y-coordinate. We can use an equation that'll tell us the relation as the set of ordered pairs, the x and y, and it'll make the equation true. We can test the equation to see if the relation is a function. In other words, it'll assign exactly one y value to each x value. So take a look at this. This is a function because each x can only have one arrow. So the 0 is going to the 3, the 1 is going to the 6, the 2 is going to the 9. And this is a function because each of these have one arrow. See? Even if the 1 and the 2 are going to the same y, that's okay as long as each one of these has one arrow. This is not a function because the 0 is going to the 3 and the 6. See? The x can only have one arrow leaving out of it, okay? So, is the relation x equals the absolute value of y a function? So we start by listing ordered pairs that fit, and we start with 1 to make it easy. Whenever you do a function table or a mapping diagram, start with a 1, and that'll make it easier to go in order, 1, 2, 3, 4. So we assign 1 to x. So if x is a 1, the absolute value of y, well, it could have been a negative y or a positive, couldn't it? Because the absolute value is the number's distance from 0 on a number line, so it could be a positive or a negative. See? So it could have been a negative 1 or a positive 1. So this relation is not a function because the absolute value of y can be two different y values, a negative or a positive, and that means two arrows are coming out of that 1. See? If we do a mapping diagram, x is a 1 in both of these, but it's got two different y values, so no, that's not a function. It can only have one y value, okay? Take a look at this one. Is the relation y equals 3x a function? So we assign ordered pairs that fit. We start with giving 1 to the x. So if x is a 1, 3 times 1 is 3, see? And if x is a 2, then 3 times 2 is 6, see? If x is a 3, 3 times 3 is 9. And this is a function because each product of 3x is unique. It's different. And there's one y value for each x value. And if we put these into a mapping diagram, we can see there's one arrow leaving each x value. We can put it in a function table and see that each x has its own function of x. See? You can write a function table this way too. Each x value has one y value. See? So if the value for x has one y value, we have a function. We can also test for functions by using what's called a vertical line test. So here we have this arrow. Our line is kind of curved, isn't it? So what we do is we draw a vertical line through it. We can draw several in different places to see what happens. And if the vertical line goes through one ordered pair, one point, then it's a function. But if that vertical line goes through two points, it's not a function. And because our vertical line went through at this point and at this point, it's not a function. Here's a circle. We do the vertical line test, and it goes through this point and this point. So no, that's not a function. It can't have two x values that are the same. See? And even here, it's a 5 and a 5. Here, it's a 2 and a 2. X can't have the same value. And in this one, there's no point in even drawing the vertical line because we can see there's a vertical line, and every single point on this line would be a -5. There's too many -5s for x. See? On this one, yeah, it is a function because when we do our vertical line, it only hits one point. See that? And even if we graph and we get 3 little lines like this, drawing the vertical lines through them, it hits each one at a different x value. So yes, all the x values are different. It is a function. And even if we have a curved line going like this, no matter how many vertical lines we draw through it, all the x values are going to be different. So yeah, it's a function. So our next video is 12.2b. We're going to talk about how to find the domain of a function. And, of course, you can check this video's description for links to the previous videos that we just did or helpful videos on this topic. We just did identifying functions a couple videos ago and function notation and operations with functions. And I'll put a link for absolute values in here if you don't remember. And in my grade 8 math playlist, because this is Algebra I playlist, in the grade 8 math playlist, the entire chapter 6 covers functions. And it goes from video 6.1a to like 6.4b or c. So there's several videos. There's at least a dozen or more videos in that playlist that talks about functions, okay? So let's talk about domains in the next video. And I hope you're doing okay. Stick with it. You can make it through this. Just take one little piece at a time and you'll be okay. All right? I'll see you next video. Bye.